right? So we just keep progressing up, right, to one step, two step, multi-step, and now it's equations with variables on both sides, which I think you will find to be not that much different than what we've already done. It's the next lesson that you will find very different than what we've already done. You put a data cable in there and you transfer data. Okay. So yeah, we would expect to have a quiz next class. So this is an example of an equation that has variables on both sides. Now, if you remember if you pay attention to the wording of this here, it says we're going to solve multi-step linear equations, right? What does it mean when they say linear equations? It means that the variables will only be raised to the first power. So you can have an x term or you could have a constant term, but that's it, right? If it's nonlinear, maybe you would have an x squared or an x to the third, and you could have many more terms. But in a linear equation, you can only have an x to the first term, and you can have a constant term. So when you see a problem like this one here, on each side of the equal sign, you have a constant term and a linear term. You know, before you start moving terms from side to side, you want to make sure that you have, just two terms, no more than two terms on one side of the equal sign. If there's more than two terms, there's some combining of like terms you have to do before you start adding to both sides. So we have constants and we've got variable terms on both sides. Generally, you could do at this step, you could do one of four things. You could subtract 7, add 8x, subtract 4x, or add 17. And you're not necessarily going to be wrong. I mean, you could get the right answer by doing any one of those as your first step. But what we recommend and what we'll always show is that we try to move the variable terms first. And we try to move them to the side which already has the bigger coefficient. Right? So generally, the starting point is, look at the two variable terms. Which one has a bigger coefficient? The two terms are negative 8x, positive 4x. Which term has a bigger coefficient? 4x. So we would want to move the minus 8x from the left side to the right side. Okay, now this is properties of equality, right? What can I do to cancel a subtract 8x on the left side? Add 8x to both sides. Right? So add 8x. And there, yes. Plus 8x plus 8x. 7 equals 4x plus 8x, 12x minus 17. Because you don't have to do that as the first step, but that's what we'll always show. Try to get them, why not move the 4x to the other side? Why not subtract 4x from both sides? Because then it'd be a negative coefficient. We're just trying to avoid negative coefficients since that's the source of a lot of errors. Okay, now this is a two-step equation. What are the two steps? You know what I'm going to do first? I'm going to switch sides. 12x minus 17 equals 7. What property says I can do that?
Just kidding. Associated.
These are the properties of equality, not the properties of real numbers. Remember, there was two of them. True? There's two properties, reflexive and symmetric. This is a symmetric one. Symmetric is the one that lets you switch side to side. Reflexive is the one that when you're checking your answer and you get down to the line that says 4 equals 4, that's reflexive property. This is symmetric. And personally, I kind of like to have the variable on the left when I'm solving, but it doesn't matter. Plus 17, plus 17. 12x equals 24. Divide by 12. So x equals 2. Again, we can check that by plugging it back in here. 7 minus 8 times 2 equals 4 times 2 minus 17. And we'll put a question mark because we don't know that that's true. 7 minus 16 equals 8 minus 17, question mark. 7 minus 16 is? Negative 9. 8 minus 17 is? Negative 9. Okay, and then by reflexive property, that's true. Okay. There's your you try. So I'm not asking what you did as your first step. What would I say should be your first step? Portia. Subtract C, right? Move the variable terms first. And if I do that, which one am I moving? The C or the 4C? The C.
At this time, would the 11th grade students who have a pass to report to the PSAT pre-administration, please report to the cafeteria at this time. Thank you.
Okay. And then now it's a two-step equation. So I'm going to flip sides again, so I've got my variables on the left. 3C minus 7 equals 20. Add 7. 3C equals 27. Divide by 3. C equals 9. Again, switching side to side, that was symmetric. Okay, now I've got a little bit of distributive property to do. I'm going to do the one on the left, and then you're going to do the one on the right. Okay. So on the problem on the left, on the right-hand side, I will distribute 5Z minus 2 equals 6Z minus 8. Okay. So the two variable terms, the bigger is 6Z, so I should try to move the 5Z. How do I, what am I going to do to move 5Z from the left-hand side? Okay, subtract. When it's the leading term, if it's positive, you don't see a sign, right? Don't get confused because there's a minus afterwards and think that you have to add to get rid of it. That's a positive, so you need to subtract it. It's a common mistake. Right. But when there is no sign, you got to assume positive. So negative 2 equals 6Z minus 5Z, Z minus 8. And now we've just got a one-step equation. Plus 8 plus 8. 6 equals Z. So try the number 5 one. 2? Let me see. 3 minus 4 times 2 would be 3 minus 8, negative 5. 2 minus 3 is negative 1. 5 times negative 1 is negative 5. So it checks. All right, this is what it would have looked like. 3 minus 4a equals 5a minus 15. Right? There's two variable terms. Which one is the bigger? 5a. So how do I move the negative 4a from the left? Add 4a. So now we have 3 equals 9a minus 15. 9a minus 15 equals 3 plus 15 plus 15. 9a equals 18. 9a divided by 9, 18 divided by 9. Those. You know, sometimes what I'll see is that we'll have, I'm going to add this as improvised. That we'll have an expression. Something looks like 5a plus 6 minus 3a plus 4. And actually, the problem says simplify. Right? There's an expression, simplify. What are they asking you to do? Combine like terms. This is not an equation, right? So you can't use properties of equality to add to both sides. But sometimes students at this step are going to show this. Right? They're going to add 3a here and add 3a here. And you can't do that. Right? It's not an equation. You can't just add 3a in two different places. That's going to give you something that's not the same. So make sure that when we're looking at things like this, it's always when you're adding or subtracting, it's the same thing from both sides of the equal sign. It should look like it's the equal sign. That's a really bad equal sign, but there's one term on that side, there's one term on that side. Right? Don't try to do the same thing twice on the same side. All right, so here's one. We add the typical next level of difficulty, which is to say there's a fraction. And what have we been learning we should do when there's a fraction? Multiply. Multiply by the reciprocal. In this case, that would be 4. It's another example of where this, I don't like the way this book operates. But okay, so let's say I go 9x minus 5 equals 1/4 times 16x plus 60. Right, I'm going to multiply both sides times 4. I'll put the 4 here and a 4 here, which means that's got to be times the whole left side, so I need parentheses now. Right. On the left, distribute 4 times 9x, 4 times negative 5. 36x minus 20. Okay, what's left on the right? Okay, what's left is what's in the parentheses. Right? The 4's cancel. That's why we did it. Okay, there's no more 4 to multiply times 16 or 60. So don't try to do that. You use that 4 to cancel the denominator. Okay, what about the parentheses? Do we need them? No, they're not doing anything. They're, whether they're there or not won't change any order of operations. So don't be confused because there's parentheses. Just lose them. 16x plus 60. Okay, now we're to the kind of like we had before, right? We've got a linear term and a constant term on both sides. We need to move the variable term, which is the bigger of the two? 36x. So let's subtract 16x to cancel it. So this is 20x minus 20 equals 60 plus 20 plus 20. 20x equals 80. 20x divided by 20 equals 80 divided by 20. X equals 4. Remember, there's the reason you're given calculators now. So don't get these little calculations wrong. Like even when you're doing 4 times 9 and 4 times negative 5, and then you should be getting those right 100%. Okay, what would be next? What? Why is that blank? There's your U try. Yes. It's a good question. Honestly, this is one that I'm not even so sure about the recommended first step, which is multiply by reciprocal. Because in the end, then what are you going to do? you're going to multiply the left by a fraction. So we just actually moved the fraction from one side to the other. What I notice here is that this 3 actually divides evenly into 6, and it divides evenly into 15. So actually it would have simplified if we just did distributive property that side. If you multiplied by 3 halves, right, 3 halves, now the 2's in the denominator, and 2 divides evenly into 8, and it divides evenly into 6. So it kind of didn't make much difference. I think in this case, what I might have done is, instead of multiplying by the reciprocal, just multiply times 3. Just get rid of that denominator. And that would have looked like this. 3 times 8y minus 6 equals 3 times 2/3 times 6y plus 15. Right? On the left, we've got 24y minus 18. On the right, the 3's cancel, but we still have 2 times 6y plus 15. So 24y minus 18 equals 12y plus 30. And then solve that. Right? Subtract 12y. Negative 18 equals 12y, minus 18 equals 30. Add 18. Uh, 12y equals 48. Divide by 4. So y equals 12. Sorry. Divide by 12. I'm the senior moment. 12 is 4. So it should have been 4. Okay. Now I'm going to do the one on the left. Actually, I'm going to do both of those. Okay, these are different. These are different, yeah. Okay, go ahead. What I'm saying is you could have multiplied by 3 over 2. You'd still then have to distribute multiplying by a fraction, which is kind of what we were avoiding by multiplying times 2/3 on the right. So instead of multiplying by the fraction, I just multiplied by the 3 because that canceled the denominator, and now I've got one line with no denominators. You don't have to do it that way. So generally, when you have fractions involved, you should multiply by the least common denominator of the fractions so you can clear fractions. Okay. We'll get more practice at that. Okay, now look and see what happens with these two. These are different, right? On the right, I got to distribute 3x equals 3x plus 4. Okay, I've got 3x on both sides, which means if I subtract 3x, I get 0 equals 4. Which, if you notice, yeah. I need to retire. Okay. Thank you. You're on your toes. Which means that 0 equals 12, which is a statement that does not have a variable in it, which means it doesn't depend on the variable, which means, is that a true statement or is that a false statement? If it's false, that means there's no solution, right? If you solve and you eliminate all the variables and you're left with a false statement, it means there is no solution for this. There's nothing you could have plugged in at the beginning that would have made this true, right? So this is false, false. So you say no solution. Now, if I do the one on the right, 2x plus 10, and I don't have any more moments, equals 2x plus 10. Again, if I can subtract the 2x's from both sides, minus 2x, minus 2x, and I get 10 equals 10. And honestly, that at that point, I can tell you that there's no variable involved, so our answer does not depend on the value of the variable. It's a true statement. That means every number solves this, right? It is always true. Now, if you subtract 10 from both sides, just because you don't like seeing that, then you would have 0 equals 0. And it doesn't matter. In either case, it's a true statement, and it does not involve the variable. So since that's true, honestly, what you're going to say about that is the solution is all real numbers. But what they're trying to get at in this book is when you have something that's true for all real numbers, that's got a name. It's called identity. Right? So this equation right here is an identity because it's always true. Identity. Okay, when it's always true. Any value you plugged in? I mean, in the end, what property is that example of? Two times x plus 5 equals 2 times x plus 2 times 5. What property is that? It's distributive property, right? So of course it's true. Yeah. No, all real numbers solve it. 0 is not the solution. 0 is a solution, but actually it has infinitely many solutions. Any number you plug in up there is going to work. You know, again, this is actually a property. We know it's true because it's a property that we've been told. We've been told this property holds, right? So we don't need to have to solve it to show that it's true. But there will be some that are not just classic examples of properties that when you solve it, all the variables drop out and you get a true statement. So that's called an identity. So you're going to try that. No solution. Because why? What did you get when you had 12 equals 27, and that's a false statement, right? And it doesn't depend on x because there's no x, right? Sometimes what I've seen students do with that step is they can't hardly believe that there's no variable, so they just kind of like introduce the variable back again, right? 9z plus 12 equals 9z plus 27. Get it? Oh, the screen's frozen. Subtract 9z. Subtract 9z. 12 equals 27. No solution. Right. Well, I know that 12 does not equal 27, but if you get a question like this, you have to say no solution. You know, what does it tell you that they're not equal? Right? Don't just stop and say, oh, not equal. You know, that the major part of that is to say no solution. And then try this one. On this one, you should have gotten 6a plus 6 equals 6a plus 6. And I don't know what that was, but I tried to wipe some spit off the screen. I mean, I can subtract 6a from both sides, and I'll get 6 equals 6. I could subtract 6 from both sides and get 0 equals 0. The truth is that at this point right here, by reflexive property, you know, this is true. And so what do you say when you get to the point where you have a statement, like I would get if I subtracted 6a? It's a true statement, but it does not involve a variable. All real numbers, which means that statement here is called what? Identity. It's an identity. It's always true. Okay. What do I need to do to this one? I just add this because they just don't have hard enough problems in the book. So what you need to keep an eye out for is, since there's more than two terms on one side, there's going to be some combining of like terms to do. There should never be more than two terms on a side before you start adding terms side to side. So simplify what you can on the same side of the equal sign. So what will the combining of like terms lead to here? Right, 8b minus 3b, right? Don't add 3b here and here, right? That would be adding 3b twice on the same side of the equal sign. Instead, it's 8b minus 3b is 5b plus 11 equals 2b plus 2. Okay, now they're completely simplified on both sides. Move the variable terms. Which one will we move? The bigger of the two is 5b, so we will subtract 2b. So now we have 3b plus 11 equals 2. Two-step equation. Subtract 11. 3b equals negative 9. Divide 3. b equals negative 3. So just there were no examples they had where you had to actually do some simplifying, combining of like terms on one side before you did this. So I just wanted to show that. And then here's to spot the errors. What's the error on the left? Okay, so Anne got this one right away. 3 times x should have been 3 times 5, 15. Okay, so that was a mistake. Second, really? Well, I mean, they subtracted the 36s first, which is, you can still be right. You can do anything as long as you do the same thing to both sides. That's not the error. So they came down to a statement that said that 0 equals 0, and they said that means the solution is y equals 0. What's wrong with that? It should be all real numbers. It's an identity, right? That's not what you learn when you get down to 0 equals 0. Right? The thing to keep in mind when you get these statements that don't involve a variable anymore, then it's either going to be no solution or all real numbers, right? It does not depend on the variable. That's why there is none. Okay. All right. That was it. That's the homework. 15 minutes, you can get it all done, I'm sure, because you guys are that good.